We drive thousands of cars across suspension bridges and spend our lives inside skyscrapers holding millions of tons of steel. We blindly trust that immense, crushing weight to hold steady. But that massive scale relies entirely on microscopic connections. The entire structural load eventually funnels down into tiny, individual welded joints holding those plates together. If a single faulty weld can trigger a localized failure and potentially bring down an entire structure, how do engineers guarantee perfection across millions of these separate joints? For decades, melting metal together was a raw, intuitive craft. A worker made structural judgment calls by eye and feel. Today, modern engineering requires absolute certainty. Raw human intuition alone cannot guarantee a building will survive a hurricane or an earthquake. To achieve world-class safety, the industry developed a rigid, dual-pillar system. Safety relies on strictly governing the exact science of the melt and verifying the specific human holding the torch. The first pillar is the science. Before a single spark flies on a real project, engineers draft a preliminary welding procedure specification, or PWPS. Think of this as a rough recipe for how a specific joint should be welded. In structural engineering, a theoretical draft is worthless on its own. This recipe has to prove it can survive extreme punishment. Engineers create a sample weld and intentionally try to destroy it. In destructive testing, machines physically pull the welded metal apart to find its breaking point. The goal is to see the raw steel tear before the actual weld gives out. They also scan the joint using X-rays, a form of non-destructive testing. They are hunting down microscopic air pockets, impurities, or hidden cracks buried inside the cooling metal. If the sample survives this gauntlet, the exact parameters are codified into a Procedure Qualification Record, or PQR, governed by strict codes like ASME or AWS. That PQR is physical proof. It verifies that the theoretical recipe actually withstands extreme real-world stress without snapping. Once the engineers have that verified test record, they generate the final authoritative document, the WPS, or Welding Procedure Specification. This document dictates exactly how every subsequent joint must be made. It locks in the exact grade of steel, the precise electrical current, the required temperatures, and the speed of the torch. This radar chart shows how these variables interact. Temperature, voltage, and travel speed must simultaneously enter this central safe zone to create a sound joint. If one parameter slips out of alignment, like temperature dropping, the center flashes red, resulting in immediate structural failure. By enforcing these rigid parameters, the WPS eliminates guesswork. It turns the chaotic act of melting metal into a strictly repeatable science. But there is a fatal limitation to the WPS. It is only ink on paper. A perfect recipe is useless without a master chef to execute it. Creating a perfect joint in a sterile, perfectly controlled laboratory is one thing. It is entirely different to do it hundreds of feet in the air, exposed to high winds on a bare steel framework. That brings us to the second pillar, welder qualification. Before any worker is allowed to touch a structural joint, they must pass a rigorous personal exam. The welder physically demonstrates that they have the raw skill, the steady hand, and the muscle memory to flawlessly replicate the exact parameters dictated by the WPS under intense pressure. This qualification acts as the critical bridge between theoretical physics and physical reality. It verifies the human is entirely capable of delivering what the document demands. These interlocking pillars are the ultimate formula for structural integrity. The WPS provides the scientific method, and the qualified welder provides the physical execution. If a worker ignores the document, or an unverified welder attempts the job, one pillar cracks. The system dissolves, guaranteeing failure. When you look at the towering skyscrapers and expansive bridges in our cities, you're looking at the physical manifestation of this exact equation. Millions of tons of steel stay suspended safely above our heads because of a strict, invisible union. Rigid engineering law, executed perfectly by human craft.